Today we start Chapter 18, Acids and Bases. The first discussion is going to be on the properties of acids and bases. Many of these we've gone over in lab, so this should go fairly quickly. Number one, acids have a sour taste, whereas bases have a bitter taste. Vinegar contains ethanoic acid, which is acetic acid. Lemons contain citric acid, so a very characteristic sour taste. Of course, in chemistry, we will never taste anything in the chemistry lab, so we don't really use taste as a way of determining an acid from a base. All acids and bases are electrolytes. An electrolyte is a substance that conducts electricity when dissolved in water. All salts, metals and nonmetals, bonded together, are electrolytes. Most covalent compounds are non-electrolytes. So if you take salt and dissolve it in water, it will conduct electricity. If you take sugar and dissolve it in water, it will not conduct electricity. So here we have a very important definition of an acid. An acid is a covalent compound, which don't conduct electricity, that conducts electricity. And we'll talk in number 5 why that is. Number 3, indicators. In an acid, blue litmus will turn red. Phenolphthalein is colorless. In a base, red litmus turns blue. And phenolphthalein will turn pink. 4, acids react with certain metals to produce hydrogen gas. Hydrogen gas is one of our diatomics, H2. So we look for H2 on table J. If the metal is above H2, the reaction happens. If the metal is below H2, the reaction will not happen. So all 3 of these metals, K, Mg, and aluminum, are above H2. So you have to be able to identify that when a metal reacts with an acid, a single replacement reaction will happen. K bumps the H out, forming H2, and then some kind of salt. So in this case, K will bond to the Cl. We then balance the equation. 2 H's to the right of the arrow, put a 2 in front. Gives me 2 H's, which I have, to the right of the arrow. K and a K. Oops, sorry, 2 chlorines. So we put a 2 in front, which gives me 2 Ks. So I put a 2 in front. And now we have a balanced equation. Magnesium reacts with HCl, bumps out H2. Magnesium bonds with chlorine. Mg is +2, chlorine is -1. So we form MgCl2. 2 chlorines, put a 2 in front, gives me 2 H's. Mg and Mg, so we have a balanced equation. Aluminum reacts, bumps the H2 out, forms aluminum chloride. Aluminum is +3, chlorine is -1, so AlCl3. A little harder here, 2 hydrogens and 3 chlorines. So to balance HCl, I'm going to put a 6 in front. So I need 3 H2s and 2 AlCl3s to give me 6 chlorines. So 2 aluminums. So a little harder, but doable. Number 5, an acid releases hydrogen ions. You must know this. The hydrogen ions are what allow water to conduct electricity. It is what makes an acid an electrolyte. A base is an ionic compound that releases hydroxide ions. Hydroxide ions have the symbol OH-. And we should start to see that if you combine a hydrogen ion and a hydroxide ion, you end up with water. So acids release H pluses and bases release OH minuses. On the next page, this came right out of the reference table. Here are typical acids and bases we use in the classroom. They ask you often which of the following is the strongest acid. For us, the strongest will be at the top of the table, and the weakest will be at the bottom. So HCl is a strong acid. Carbonic acid is a weak acid. Also with the bases, our strongest bases will be at the top, and our weakest bases will be at the bottom. I think that's enough for our first lecture. So nothing too difficult, but you need a strong foundation, so make sure you understand everything we talked about here.